Okay, class. Now we go to the bottom of the page here. It says represent the shaded part of each figure group's area as both an improper and a mixed number. So what we do is this here. You notice that we had two separate figures here. They're the same, and they're cut into 1, 2, 3, 4 equal parts. 1, 2, 3, 4. So our denominator would be 4. Now we're going to write the improper fraction first. So our denominator is 4. So we count how many shaded parts we have here. We have 4 here plus this 1. So that gives us 5. Now that is our improper fraction. So you could write down improper is equal to 5/4. Now we could write down the mixed number. Okay, our mixed number. How many whole parts do we have shaded here? We have one whole part shaded. Now, our denominator of our fraction will still remain the same as the equal parts. So it'll be 4. So we have one whole number, our denominator is 4. Now we have to ask ourselves, how many pieces are still shaded after we take out the one whole part? It's only one that's shaded. So our mixed number is 1 1/4. Now we go to problem number 2. Again, we can start off with our improper fraction. And also I'll write down the mixed number. Okay, our improper fraction. First of all, we notice that each one of these figures are cut into 3 equal parts. So our denominator will be 3. Our shaded parts are, we have 3, 6, 7, 8. We have 8 shaded parts. So this is our improper fraction. Now for our mixed number. We have 2 whole figures shaded in here. So our whole number would be 2. Now our denominator of the fraction will remain 3. And our numerator would be the other shaded parts that are not part of the whole figures that are shaded. So we have 2 additional shaded parts. So it's 2 2/3. Now we come down here to section D. It tells us the following steps may be used to write a mixed number as an improper fraction. To write a mixed number as an improper fraction, we multiply the denominator of the fraction by the whole number. Step 2, we add the numerator of the fraction to the product from step 1. And finally, step 3, write the sum from step 2 as the numerator of the improper fraction over the original denominator. So, from this explanation, I would tell you first the easiest thing to remember. The easiest thing to remember is whenever you're changing a mixed number to an improper fraction, your denominator stays the same all the way through. So this denominator does not change. Okay, now to find our numerator, this is what we need to do. We take our denominator times the whole number. We add 3 times 1, which we have here. This is step 1. Then we add the original numerator to step 1. So we'll have 3 times 1 plus 2, and our denominator stayed the same. Now using the order of operations, we have multiplication and addition. We do the multiplication first. 3 times 1 is 3, and we bring over our plus 2. Our denominator stays 3. Now we add our numerator. 3 plus 2 is 5. Our denominator stays 3. So our final answer here, 1 2/3, a mixed number changed to an improper fraction, 1 2/3 become 5/3. Now we do example set D. Write each as an improper fraction. So, let's go through this step by step. The first thing we know is that our denominator will remain 7. That's the first thing. The second thing we know is we would take our denominator, multiply it by the whole number, and add our original numerator. So we have 7 times 2 plus 5. Now in using our order of operations, we would take 7 times 2, which is 14, plus 5, divided by 7. 14 plus 5 is 19, divided by 7. So our final answer here is 19 over 7. Now we go to problem number 2. Again, our denominator stays the same. Our denominator is 3. Now, we take our denominator times the whole number plus the original numerator. So in doing our order of operations, 3 times 5 is 15 plus 1 still will be all divided by 3. 15 plus 1 is 16 divided by 3, and that is our final answer. Now we come down here to number 3. Again, what do we know about our denominator? You're right, it stays the same. Our numerator, we take our denominator times the whole number plus the original numerator. 10 times 9 is 90 plus 3 all over 10. 90 plus 3 is 93 divided by 10. And that is our final answer. Now for number 4. Again, what do we know about our denominator? You're correct. It stays the same. Now to get our numerator, what do? You're right. We take our denominator times the whole number plus our original numerator. So we carry over our denominator here. 5 times 1 is 5 plus 1. And 5 plus 1 is 6, and it's divided by 5. Now we come to section E, writing improper fractions as mixed numbers or whole numbers. We could come down here where it gives us the explanation of how to do that. Okay, step 1, we divide the denominator into the numerator. Step 2, the whole number part of the mixed number is the quotient. The fraction part of the mixed number is the remainder over the original denominator. Okay, we're going to look at the definition used in practical usage. To change an improper fraction to a mixed number or whole number, we start by identifying the numerator and denominator, then translate the fraction into a traditional division problem. So we have 5/3. Our denominator is 3, our numerator is 5. This fraction means this division problem here. So 3 goes on the outside, 5 goes in the inside. Your denominator goes on the outside, numerator goes on the inside. Now we come down here. We have 5/3 colon, and then we had converted this to the traditional way we write a division problem. And we say 3 goes into 5 one time. 3 times 1 is 3, and we know 5 minus 3 is 2. Now, that leaves us with our remainder of 2. Let me write that here. So this leaves us a remainder 2. Now we go here, step 2. We still have our 5/3, and it's equal to. This 1 here would be the whole number of your mixed number. Now, this 3 that we were dividing by would still remain your denominator. Your remainder of 2 will become your numerator. So this is your mixed number, 1 2/3. Now, we come here to problem number 1. We want to change this to a mixed number because the direction says write each as a mixed number or a whole number. So, we change this to a traditional division problem. We will have 5 goes into 9 one time. 9 minus 5 is 4. So we have a remainder of 4. Now we want to write this as a mixed number. We know this number here will be our whole number. Our denominator stays the same. Our numerator is the remainder. We're done. It's 1 4/5. Now we go to problem number 2. We would take 9 into 23. We know 9 does not go into 2, but 9 does go into 23. It goes in twice. So 2 times 9 is 18. 23 minus 18 is 5. Our remainder is 5. Now, to write this as a mixed number, this 2 is our whole number. Our denominator stays 9, and our numerator is the remainder, which is 5. Now we scroll down to problem number 3. Now what we need to do here is the same thing. We would take 4 into 48. 4 goes into 4 one time. Now we know 4 minus 4 is 0. Then we bring down our 8. 4 goes into, we know 0, 8 is just 8. 4 goes into 8 2 times. 2 times 4 is 8. 8 minus 8 is 0. We have no remainder. So our final answer here is just 12. Now we go to number 3. We would take 13 into 62. Now we know 13 does not go into 6, but 13 goes into 62 4 times. 4 times 3 is 12. Carry the 1. 4 times 1 is 4, plus 1 is 5. 62 minus 52 is 10. So we have a remainder of 10. Our final answer, our whole number is 4. Our denominator stays 13. And our numerator is the remainder, which is 10. Now we scroll down to our last 2 problems of this section. We take 7 into 51. 7 goes into 50 times. 7 goes into 51 7 times. 7 times 7 is 49. 51 minus 49 is 2. So we have a remainder of 2. Our whole number is 7. Our denominator stays 7. And our numerator is the remainder, which is 2. Now we come to our final problem. We need to take 20 into 21. 20 goes into 21 one time. So we would say 1 times 20 is 20. 21 minus 20 is 1. So our remainder is 1. Our final answer, the whole number is 1. Our denominator stays 20. And our numerator is 1. So our final answer is 1 1/20.